Good morning. Oops, wrong manual. Hold on. There we go. It's PO26. So we are continuing with those percentages, but now we are doing a power objective. So we really need to understand how this works. We are finding a part, whole, or percent using an equation or proportion. Okay, so we're going to break this down so we understand what it means. Just reading that sounds confusing, but let's really focus and pay attention so it will make sense to us. In every situation involving a percentage, there will be three components: a part, a whole, and a percent. So the part is represented by using the P. The whole is represented by using the W. And percent is represented by using the percentage sign. So in each example below, identify the part, the whole, and the percent. So if we look at that, 72 is 90% of 80. Which number is my part? Tatum? 72. So we're going to put a P under that. Which one's the percentage? This is the easiest one. Priya?
90.
90. And so which one is our whole? 80. That's the number that we start with. We were calling it the original. That's your whole number, right? So that's the whole. So let's look at the next one. 16% of 30 is 4.8. So what is my part? They worded it differently. Means the same thing, but they worded it differently. Evan? 4.8 is the part. 16% of 30 is 4.8. So 4.8 is that part. That's the 30% is 4.8. So 4.8 out of what number? It's out of 30. The percentage is the easy one. 16% is our percent. Now let's see if we can figure out the fractions. I want you to think about what we've learned about percentages. Evelyn, what do you think the part is?
The part is 20.
Just 20 is our part. It's 20 out of how many? Ben?
25.
25. That is our whole. Well, goodness, we have percentage left, and all of a sudden I don't see a percent sign. Well, snap-a-doodles, what is my percent, Kate? 80 over 100, because we know our percentages can be that fraction. It's over that 100, so that whole fraction, 80 over 100, we could say as what percent? 80%. So 80 over 100 is our percentage. That is 80%. It's just written as a fraction instead of the percent, but it's over that 100. Does that make sense? Feeling good with this? Show me your thumbs. You feel good or we're not sure? Okay, I have a couple people that are like, kind of there. So, your whole, listen to this, your whole is going to be the big number, right? That's what we're starting with. If our percentage is under 100%, the part is going to be small because it's less than your whole. If our percentage is under 100%, the part will be smaller. Does that make sense?
Yeah.
If our percentage is over 100%, is our part going to be smaller or bigger than the whole? It's going to be bigger because it's over 100. It's over that much. Percentages are easy to find because we either have the percent or it's a fraction that we can put over 100. When we are working with those fractions, think about it as a test score. 20 out of 25 on our religion quiz. There were 25 points possible. I got 20 correct out of 25. So the part is how much I got correct. The whole is how many possible points. So we've seen this on our test scores. We've seen the fraction and how to turn that into a percentage. Thus,
The percentage also be a decimal?
it could be, yes. Percentage could be a decimal. We know fractions, decimals, and percents are all related. So, finding a part, whole, or percent can be set up in two different ways. One way is doing the proportion. That's the fraction way. So we could do part over the whole equals that percent over 100. So if we're working with a proportion, it's the part over whole equals percent over 100. We could also do it as an equation. You could do it as the part equals your percent times the whole. So we can do it either way. I'm going to show you how we can use these equations to answer our questions. So we're going to find the part, the whole, or the percent using both methods above. We're going to show how to use that. And we're going to show how we use our knowledge of algebra that we've done to solve for the variable. Okay, our variable is either going to be part, whole, or percent. We're going to solve for our unknown. And we're going to, how do we solve for that unknown, for that variable? We do our opposite operations to get the variable by itself. We've already done this. We know this math. So we're going to start with our proportion. What number is 35% of 70? So what is my proportion going to look like? What's my part? Do we know it? So what am I going to write? P. Because we're going to use the variables that we just defined. So we're not going to put n or x. We're going to use the variable that we just defined. So we're looking for our part. Part goes over whole. What's our whole? 70 equals, what's our percent? Over 100. So now we want to solve for our part. Remember doing the opposite operation so we get part by itself. What math do I have to do? Emily? Yeah, what am I, because I'm dividing here. What do I have to multiply each side by? No, I have my part. It's divided by 70. I want part by itself. Multiply by 70. Because I was dividing by 70, I'm going to multiply both sides by 70. So now I have part by itself, because multiply dividing cancels out, that's 1. Now I have to do 35 times 70. 124. So I get 2,450 divided by 100. So 35 times 70, right? Now I need to divide it by 100. Somebody just whispered it. What is it, Evan? 24.5. If I were to work it out, and actually go through and divide it, 100 goes in there 2 times. Or you could just to say, hey, there's 2 zeros, I need to move that decimal place over 2 points. What? 2,450, if we want to divide it by 100, there's 2 zeros. Easy, simple solution is saying, oh, 24.5. Yeah, it's a little cheat on there. Little tidbit. Evan. So P equals 24.5. That's if we're doing it using our part whole equals the percent over 100. Now it does say we have to do it both ways. So now we need to do it part equals percent times the whole. So we don't know our part, that's what we're going for, times percent, 0.35 times our whole of 70. So we're going to do 0.35 times 70. $35, 24, 2 decimal places, so we go over 2 decimal places. We get the same answer.
Can you just show your work and all the math that you do and all your multiplication while you're doing it?
Yeah.
It says show.
It says show your work. So that's why I said if we need to get a piece of loose leaf paper to show our work, do that. Okay, get that piece of loose leaf paper and you can keep it in your binder. Evelyn.
Is it the measurement in this binder, would that also work for the CS?
I would have to look at how that works, if it's the same or if it's different. Because that was increasing and decreasing. Now we're doing percents using it's a little bit different. I would have to do that separately. Okay. Audrey.
Can we just like the sheet next to it to show?
Yeah, but you definitely can use that blank side of the paper right next to it. Just know that you might run out of room, so don't write it really big. Okay, keep it organized so you know. On this page, it's easy because there's only 3 of them, right? But when we turn the page, there's a whole lot more. So if you need to do a loose leaf paper and put it in there, you can do that. I've got loose leaf on the back counter. But we're not done, friends. We need to figure out how to do the rest. Do you guys want me to go through another one? Yes. Figure. So 48 is what percent of 120? How do I set that up as a proportion? Evelyn.
38 over 120.
Because 48 is our part, 120 is our whole.
Equals to, over 100.
So we have our percent sign over 100. So what am I solving for this time? Aiden? The percent. So what math do I have to do? Evelyn? How do I get the percent by itself? What's my opposite operation I have to do? I was dividing by 100, so now I need to multiply each side by 100. So multiplying and dividing cancels out. So 100 times 48 gives me 4,800 divided by 120. So I know my zeros cancel out, right?
Mm-hmm.
So now I have 480 divided by 12. 12 goes into 48 4 times with 1 0 left over. So my percentage is 40%. Aiden, was that, I have no idea what you did, or whoa, that's how you do it? So 100 times 48. Yep. 100 times 48 is 4,800 over the 120. I know I can cancel out the 2 zeros if I divide a 10 out. So now I have 480 divided by 12. Well, I know 12 can go into 48 4 times, and then I have that 1 0 left. So it gives me my 40%. Can I go and do the long math with it? Sure can. So if you're more comfortable doing that long math, do the long math. Tatum?
So you multiply the numerator by the.
So we wanted to get the percentage by itself. So opposite operation, we multiplied by 100. So let me work it all the way out for us. So 100 times 48. So 0048. So that's how I got my 4,800 divided by 120. Then I can go and I can do the long math. Let's do the long division. 4,800 divided by 120. 120 can't go into 4, can't go into 48. It can go into 480 4 times. 4 times 0 is 0. 4 times 2 is 8. 4 times 1 is 4. So I subtract that out, I get 0. I'm going to bring down this 0. 120 goes into 0, 0 times. So that's how I get my 40%. So that's the math you have to do. I was doing the shortcuts because I've been doing math for a long time. So I'm just giving you some sneak peeks at some shortcuts you can do. You don't have to do the shortcuts. Do the long division if that's what you're comfortable with. Aiden.
Can we do the last one too? Yes.
We have to finish this one first. Because remember, we have to show both methods.
What?
Show both methods. We did both methods with this one. We have to do both methods with this one. So our second way of doing it is the part, which was our 48, equals the percent, which we don't know, times our whole. So this time, if we want to get percentage by itself, what's the opposite operation we have to do? James? Division. I was multiplying by 120, so now I need to divide by 120. So now I'm going to do 148 divided by 120. 120 can't go into 48. So do I say, what? I can't do it?
Nope.
What do I do, Tegan? I can just add random zeros on?
Then you add a decimal.
I have to put a decimal. Don't forget that decimal. You can't just turn 48 into 4,800. You have to put those zeros on. So 120 can't go into 48, but 120 can go into 480 4 times. So we carry that decimal straight up. 4 times 0 is 0. 4 times 2 is 8. 4 times 1 is 4. Subtract it, and I get 0. So it's 0.4. So what percentage is 0.4? Tatum? Yeah. So if it's 0.4, that translates into 40%. That makes sense?
Yes.
Okay, last one. All right, Evelyn.
It would be 18 over W, which I don't remember, and then 25 over 100.
Perfect. Our part 18 is 25% of what number? Of what is our whole? So that of is telling us that it's over the whole. 18 is the part over the whole equals our percentage of 25 over 100. How do I do this one? My W is on the bottom. Oh, Miss Gambino, we're throwing in some new thoughts here.
Yay.
Anybody have an idea of how to solve this? Evan, what do you think?
Would you multiply it by 18?
Alexis?
18 times 18.
So, that's one step. If we times that 100 to get that 100 off the bottom, now we have 1,800 W equals 25. Yeah, we're getting there. 25, right here. So we multiplied by the 100. 100 times 18 is 1,800. We're still over the W, equals 25. Guesses on what we do next? Emily. So if we divide by 25, we're dividing by 25. What is 1,800 divided by 25? So that would be 35, 14 plus 3 is 17. 25 goes into 50 twice. So we get a 72. So I have 72 over W. 25 divided by 25 is 1. How do I get my W to the other side? So it's up on top. Because what's 25 divided by 25? 1. So 25 divided by 25 is 1. What's my last step that I have to do? There's one simple last step, and you're going to go, oh, I didn't know we could do that. What do you think it is, Tatum? Nope, because that's not going to get my W to the other side. My W's on the bottom right now. I don't want the W on the bottom. It's not just switching it. What math are we doing? We're going to times it by W because we are dividing by W. So that cancels this out, so it's just 72. 1 times W is W. So we're not just switching it. The math that we're doing is we're multiplying by the W. If the W's a denominator, the way to get it as the top on the other side is to multiply, to do that opposite. This way is a little bit more complicated when we're having to find the variable that's on the bottom. It's complicated, but there are these steps that we're following. Is there paper out, Emily? Go in the cupboard right above it, and I have a whole bunch. Oh yeah, take one of those. I've got lots of loose leaf for us to use this year. Does that make sense how we got the whole to be 72? Yeah. It's a little more complicated when we do it with the proportions. Let's look to see what it looks like when we do it with the equation. The equation is going to be a little bit easier. Tatum? Hold on. Say that one more time. Yeah, you could have simplified it. You could simplify it right from the beginning and make it easier numbers to use. But you still have to, at the end, multiply both sides by W to get the W to the other side. You definitely can simplify and make it easier numbers to use. That's why we learned about simplifying. So now, let's do this using the part equals percent times the whole. Our part was 18 equals our percent, which is 25, right? 20. At 25, right? So we're multiplying it of the whole. So the 25 of the whole with 0.25. It's been a long day. Just making sure we're following along. So 18 equals 0.25 times W. What math do I have to do to get my W by itself? Emily. The W's up on the top. We want that W alone, so we're not going to divide by the W. We want to keep the W there. Emily? Remember, it's 0.25 because it's percentage. So we're going to divide out because we want to get the W by itself. Right now we're multiplying. We want to divide it out. Doing that opposite operation. So we're going to do the long division. We're going to move the decimal point over 2 places. So now it's 25 divided into 1,800. Look at that. 25 divided into 1,800. If we did that long math, 7 times 25 is 175. It's been a long day. Which gives me 50. 25 goes into 50, my 2 times. Which one was easier to do? The second one, the equation. For me, the equation was easier. Instead of doing the proportions, the proportion looks kind of confusing. But if you know how to take that proportion and put it into the equation, as long as the important things to know is the part, which number's the part, which number's the whole, where's the percentage, and then you can take it and put it into the equation to work it out that way. So let's look at what our work is for today. Well, we did 1 page. So we've got word problems. Word problems take up a lot of space on the page, so it's not as many problems as you think. Most situations for which you'll use these methods are real life situations. Answer each question below showing your work. Round your decimals. If you get a decimal, you're going to round it to the nearest tenth. So, can we use a calculator on the test? Remember, I looked it up the other day and I showed you we cannot use the calculator on the test. So you have to do the math. Show your work. Don't do the math on your whiteboard because that's not showing your work. Okay, show the work on a piece of paper, put it into your binder. So if you get it wrong, we can see where the mistake happened. Priya. So let's do this first one together. Your bookshelf has 150 books in it. 20% are on the top shelf, 50% are on the middle shelf, and 30% are on the bottom shelf. How many books are on each shelf? So we need to know our part, we need to know the whole, and we need to know the percentage. What is the variable that we're looking for? James?
The part.
Yeah, we're looking for the part. How many are on each shelf? So we're looking for the part. Because we know our whole is 120. I like to see which numbers work easier if I'm going to do the proportion or if I'm going to do the equation. If we set up the proportion, we would have part over 120 equals 20% on the top shelf, so 20 hundredths. Sorry, you're right. 150, not 120. Nope. So, for my friends who said, hey, can we simplify fractions to make it easier numbers? And I said, oh, of course you can. Can we simplify 20 hundredths to 1/5? So now we have part over 150 equals 1/5. So look at that. I know I want my parts by itself. So what math am I going to do? Oh, you took it a step farther. So you took it to the next step.
Good afternoon.
Multiply by 150.
Drama calls all cast to rehearsal this afternoon. And would the following students please come to the office to pick up something for Girl Scouts? Ava Quira, Olivia Angel, and Brynlyn Mitchell. Please come to the office. Thank you.
Okay, so we have 150 cancels out. 1 times 150, 150 over 5. So what's 150 divided by 5? 30. So on the top shelf, it's 30. So that answer for the top shelf. We have to do the same thing for the middle shelf, same thing for the bottom shelf. So there, 30 of the books will be on the top shelf. 50% are on the middle shelf. Oh, friends, 50% are on the middle shelf. Do I have to do all kinds of math for that? What would be 50% of 150? Yeah. I'm not going to make you do the math on that one. 50% of 150, we know is half of it. So we know there's 75. Now we need to know the bottom or middle. If we know how many are on top and how many are on bottom, do we have to do a whole ton of math to figure out what's on the middle? What can I do? Seriously, everybody stop and let's think this one through. If I know how many are on top, I know how many are on bottom, I know how many all together there are. This is our pattern pages that we do in our math packets. What can I do easily, Kate? Yeah. 30 plus 75 is 105. 150 minus that 105 gives us how much, James?
Wait. I was asking.
Okay.
Is it middle 75 because it says 50% are
Oh,
in the middle?
good catch, James. Thank you. I'm going too fast. So the middle was 50%. I went too fast. So the middle is that 75. So the bottom is the 150 minus the top minus the middle, and I'm left with the bottom. Did I have to do a whole ton of math to solve it? No, I didn't have to do it every single time. Sometimes we can think things through. Just stop and pause. Don't be overwhelmed going, oh my goodness, I have to do all this math and then do every single step. Sometimes we can make it easier on ourselves by that. Not every time, but sometimes we can. So just take a breath and stop and think. Your homeroom has sold 120 raffle tickets, which is 40% of your goal. How many tickets is the goal for your homeroom? Yeah. So let's do it this one with the equation. What's my part? What do I start with? Oh, who just said that? Gus, what did you say? The part is what you don't know. Because your homeroom has sold. Oh, wait. No. We know the part. We've sold 120 tickets. That's 40% of our goal. Then it says how many tickets are in the goal. So it's 120 is 40% of the goal. So when you see that word of, that's going to be cluing you in. That's your whole. Of your goal, of the whole. So our part is 120. Then we have our percentage times the whole. We want to find the W. So what math do I have to do to get W by itself? I'm going to divide out that 0.40. So 120 divided by 0.40. Move my decimal place over. 40 goes into 120 3 times. 3 times 40 is 120. Bring down my 0. 40 goes into 0 0 times. Bring down my next 0. 40 goes into 0 0 times. So 120 divided by 0.40. So when we divide a decimal, right? Because it's 0.40. We're dividing that decimal into, I don't know what just happened there, into 120. We can't divide that decimal. The rule for dividing a decimal is you move it over. And if you move this decimal over, you have to move this decimal over. So then we fill in zeros there. So instead of 0.40 divided into 120, it's 40 divided into 12,000. Because you move that, if you move the decimal place over on the left, you have to move that decimal place over on the right. That's why there's so many zeros. Does that make sense?
Yeah.
Move the decimal on the left, so you move the decimal on the right. And then that's how we got the 300 instead of 3. That makes sense? So W equals 300. That's our goal, 300 tickets. So here's how our math is supposed to play out over the next few days. We have tomorrow, we have an objective that I want to do. Monday, we had an objective to do, and Tuesday was going to be kind of a free day because it's the day before vacation. So we were going to do like any retakes that we had to do, any work that we have to do. Because I know there are going to be even more people gone on Tuesday. So, question to the class. Do we want to do this as homework and stay on task, do an objective tomorrow, do an objective Monday, and then have Tuesday as our kind of a free day to catch up on stuff? So that way my friends who are going to be gone will at least get the next lesson in class. Or are we gonna keep working on this objective tomorrow and then do objective 27 on Monday and objective 28 on Tuesday?
I want to do the second option. First
So let's take a vote. How many want to keep on task and do it this way to help out our friends who are gonna be gone next week? Raise your hand. 9, 10, 11. Okay, how many of us want to continue to work on this tomorrow and have 2 objectives next week? 2, 3, 4, 5, 6.
I do time for science tonight.
Okay, so here's what we're going to do. I want you to dedicate half an hour of work time tonight to work on this. So dedicate at least half an hour tonight. It's fair enough to say half an hour of math work time. Then we're gonna see where we're at tomorrow. And because we were kind of tied with our numbers. So we're gonna make a final decision tomorrow. If you are listening at home, work on finishing these out. We hope you are well, and we hope to see you soon. Have a good day.